Welcome to the Staff Productivity module. As you learned in the previous modules, Cloud Economics covers business value and cloud financial management. This module continues to focus on business value. By now, the Cloud Value Framework should look familiar to you. In this module, you will learn about staff productivity, which is the second pillar of the Cloud Value Framework. Staff productivity refers to the efficiency gained from reducing or eliminating tasks no longer needed with cloud services. For instance, by migrating to AWS, your customer's staff will spend less time on infrastructure and have more time to focus on new projects. As enterprises move to AWS, a few common patterns emerge at the IT staff level. Tactical, undifferentiated work previously required for traditional data centers, like provisioning resources, moves from manual to automated. This saves time and reduces time to market. This allows your customers' resources to move to more strategic work. As AWS maturity increases, customers learn how to further improve their businesses with AWS. They adopt new services and technologies, which can result in additional cost reductions and accelerated time to market. IT team members who used to work on projects like storage array deployments and server refreshes can transition to become DevOps specialists. By being integrated into the dev team, they can support the development of new products and services. While AWS does not provide tax advice, customers often comment that those IT team members are so integrated into the dev teams that their tax auditor instructs them to capitalize on those team members, the same way they would capitalize on developers. This might be something your customer could explore. In August 2018, AWS did some benchmarking analysis. We asked customers what benefits they achieved by using AWS. On the staff productivity side, we found an average 2 times increase in the number of virtual machines, or VMs, managed per administrator, and 1.8 times increase in number of terabytes managed per administrator. These are powerful statistics. However, the question often arises: what happens to the quality of the products being developed as efficiency increases? An indicator of quality is the reduction in number of incidents, and we found an average of 43.4% reduction in total incidents. With these benefits in mind, take a look at typical IT roles and how efficiency can be improved by moving to AWS. In calculating staff productivity efficiency gains, AWS looks at 6 main categories of IT-related functions: server, network, storage, applications, facilities, and security. While each organization is different, we find that these are the typical functions. The first 3 IT functions, server, network, and storage, center around managing hardware infrastructure. Typical roles include administrators, implementers, and engineers. Staff productivity includes application functions, covered by roles such as database administrators, app dev, QA, and support functions. Facilities functions primarily cover facilities management and include roles for customers who have an on-premises data center. And finally, security functions help enterprises ensure that their infrastructure meets compliance, regulatory, and corporate standards. Each function has a role or roles to support it. Each role has approximately 10 to 15 primary activities. In our modeling, which you will see next, we estimated time spent on each of these activities before moving to AWS and calculated the reduction in time spent after moving to AWS, where applicable. The first example shows our finding for the server functions. This model shows the typical activities a server administrator completes to support the server functions. As you can see, certain tasks like patching are significantly reduced. Here you can see that installing, upgrading, and removing software is reduced by half due to AWS simplicity and automation. Other tasks, like arranging for hardware repair, are completely eliminated. In this example, the arranging repairs for hardware in occasion of hardware failure task is eliminated completely, because the customer no longer has physical hardware. When you calculate staff productivity benefits for your customers, remember that it's a collaborative process between you and your customer. Ultimately, your customer will need to justify the numbers when they present a business case to leadership. This model addresses network functions. Network roles include administration, engineering, and implementation. Here are some of the typical activities related to supporting a physical network. As you can see, certain tasks, like network planning, are significantly reduced. With AWS, the purpose of network forecasting changes. Traditionally, the focus of forecasting was to provision hardware and buy more equipment. Now the purpose of forecasting is to understand the cost. Without AWS, an incorrect forecast meant your customer might not deliver on a service level agreement, or SLA. With AWS, an incorrect forecast means your customer might pay more than they estimated, but their customers and SLAs will not be affected. In addition, you can see some tasks, like upgrading hardware, are completely eliminated. Your customers don't have to manage their network when they use AWS. The customer selects the services they want to use, and then AWS takes it from there. Your customer doesn't need to conduct any maintenance tasks like installing network patches or upgrades. This model addresses storage functions. It shows typical activities related to supporting physical arrays of storage in a data center. Certain tasks like preventative maintenance are reduced because they are managed by AWS. Other tasks, like hardware installation, are eliminated. You can see a 100% savings here because there are no physical arrays to implement. This is the application functions model. In this case, you can see typical activities related to coding, testing, and supporting business applications. Similar to other functions, certain tasks like testing require less time due to AWS automation and self-service. Other tasks, like provisioning a new environment, are greatly improved. Here is the facilities function model, which includes roles in facilities management and infrastructure project management. As you can see, certain activities like hardware-related disaster recovery planning and testing are greatly improved. Whereas other tasks like managing power and cooling systems are eliminated because AWS handles those tasks for customers. The final model is the security functions model, which includes roles like security administration and engineering. Here, you can see the administration of security tools, like vulnerability scanners, are greatly improved due to using a central platform. And other activities like security audits are greatly simplified, which helps companies increase adherence to standards and identify risks faster. By putting the model data together, you can create a detailed look at the benefits AWS offers relative to traditional infrastructure roles. While the modeling can go deep into every role, the overall output can provide an executive-level view on where efficiency gains can be achieved. In this case, a customer achieved a 39% improvement in overall efficiency by using AWS. While this is conservative, the example reflects two important concepts. First, the information resulted from a partnership where the customer actively participated and provided data based on the impact they could achieve. Second, the customer fully owned the business case. While modeling can provide specific guidance around the economics, your customer is the one who needs to understand and be comfortable with the benefits. Here's another example of quantifying the benefits customers achieve by using AWS. This example focuses on the application developer efficiency as a customer moves their applications to AWS and migrates to a full DevOps operating model. In this case, modeling indicated a 15% efficiency gain by migrating to AWS. This was primarily driven by the reduction or removal of non-coding tasks, like receiving a server and creating a standard dev environment. In addition, as the customer invested in optimization of their software development process, particularly around test and release management processes, they experienced an 11% improvement in overall productivity. Finally, as they move towards a fully continuous integration and continuous delivery, or CI/CD model, they have improved build and deployment management. So far, they have reduced coding tasks by 18%, which has resulted in fewer defects and higher quality code. AWS customers are realizing value around staff productivity. Intuit's Senior VP of Platform and Services identified that 60% of her team's time was spent on heavy lifting tasks. Part of the value with AWS is that now her employees can focus on more differentiating tasks. AdRoll estimates that it would need to hire at least 20 full-time engineers to effectively manage the physical environment if they weren't running on AWS. That would include 8 full-time employees on call across 4 different data centers, 2 in each location for redundancy, 1 product manager for automatic scaling and API management, 5 engineers to develop and maintain automatic scaling across the infrastructure, 5 engineers to maintain Cassandra installation instead of DynamoDB, 1 engineering manager. The overall annual staffing costs with an average engineering salary of $150,000 would be $3 million. These resources are now focused on their core real-time bidding system. Finally, a pharma services provider conducted their own analysis around staff productivity. They worked with various functions across the organization. They found a 31% overall improvement to IT roles. And just as importantly, they found they could reduce or eliminate Gate 0 and Gate 3 design and build tasks through automation and self-service deployment, which improved their time to market of new products and features. In this module, you learned how to explain the concepts of staff productivity and explain how to quantify the impact AWS has on staff productivity. Thank you for completing the staff productivity module. Welcome to the Operational Resilience module. This module continues to focus on the business value aspects of cloud economics. Previously, you were introduced to the Cloud Value Framework and its 4 pillars. You have learned about the cost savings and staff productivity pillars. In this module, you will learn about operational resilience, which is the 3rd pillar in the Cloud Value Framework. Operational resilience is the benefit gained from improved availability and security. This means more uptime, less downtime, and decreased risk. When you and your customers think of operational resilience, 2 words should come to mind: uptime and security. Keeping an infrastructure operationally resilient and available involves multiple components, from the network layer to servers and storage to the database layer. Each component of an application needs to be available. Downtime results in macro effects on business, often with significant consequences. For example, an airline's data center outage grounded 2,000 flights and cost over $150 million. A bank suffered prolonged downtime due to a distributed denial of service or DDoS attack, which impacted customer confidence. A sales forecasting application caused inability to report guidance to the street, causing a disruption to sales and finance, and ultimately leading to an inability to report guidance to Wall Street. And a major retailer suffered a data breach, which cost $252 million. Overall, you can see that a lot of losses are involved with decreased operational resilience. The impacts of downtime are not cheap. These downtime events cost the Fortune 1000 companies between $1.25 and $2.5 billion annually, with critical application failures costing up to $1 million per hour, according to IDC. The average cost of a data breach was $3.6 million per hour. The cost per hour of downtime events cost $336,000 per hour, according to Gartner, and $474,000 per hour, according to the Ponemon Institute. These downtime costs include third-party fees, equipment replacement, after-the-fact incidental costs, recovery activities and costs, detection costs associated with initial recovery and subsequent investigation, unproductive IT staff and end-user costs, lost revenue, business disruption costs, and more. Many times, causes for downtime are not external attacks. Downtime often occurs because the demand for services exceeds the infrastructure's ability to meet the demand. When we want to quantify the impact, we use leading research from third parties to help guide the business. An interesting insight here is that the cost of business disruption is higher than the cost of lost revenue. That means the damage to the company's brand, customer churn, and lost opportunities are greater than the revenue loss. Even for internal applications, you can see that business productivity leads to tremendous downstream costs for a business. In addition, business disruption equals additional economic losses, including reputational damage, customer churn, and lost business opportunities. Now, think about operational resilience in the context of IT. Operationally resilient IT organizations depend on the health of 4 cornerstones: operations, security, software, and infrastructure. What do these mean? A good way to understand these cornerstones is to see how AWS helps build and reinforce each of these elements. Some primary causes of operations failures are human errors, such as lack of clearly defined procedures or user privilege, configuration errors in hardware or Let's say an employee, Mike, walks into a data center and sets his coffee on top of a server. As we all know, the likelihood of Mike's coffee being spilled into the server is proportional to the importance of the server. The human factor here is that neither Mike nor anyone else should ever enter a data center with a cup of coffee in the first place. But Mike's human, and humans make mistakes, especially when they are overconfident. So why doesn't this happen at AWS? We have all the necessary ingredients: coffee, servers, and humans. What makes AWS better in this case? Most of your customers run a data center because they have to, not because it's their business. Their business is usually to write code to run a dating site, or produce forklifts, or design beauty products. For AWS, running data centers is our business. And because it's our business, we are diligent with our rules and stringently enforce them. How does AWS mitigate operational disruptions and disaster? AWS leverages automation, manages services from end to end, provides system-wide visibility for usage, performance, and operational metrics, enables security and governance configuration of AWS resources, and monitors API access. AWS manages this by focusing on automation, simplification, and consistency in the way AWS delivers services. The causes for security breaches include malware such as worms, viruses, and Trojan horses, network attacks like open ports, SYN floods, and fragmented packets, unpatched applications or operating systems, security issues such as password disclosures, social engineering, credentials not stored securely, non-strict password policies, and poor privilege and access management, and poor or limited authentication. Remember Mike, just as he finished cleaning up the coffee spill, he was asked to allocate some storage to store sensitive data that requires health regulations compliance. Mike didn't have compliant storage available, so he decided to temporarily store the data unencrypted. After all, the new storage array that they ordered for that workload should be arriving in a few days. What's a couple of days? Not a big deal, right? Well, that same day, a hacker found a vulnerability in Mike's data center and downloaded the sensitive data. Why wouldn't that happen with AWS? With AWS, Mike would not have had to make a judgment call. With AWS, all resources are a click away. Mike could have provisioned a health regulations compliant encrypted Amazon S3 bucket in just a few minutes. AWS has a shared security model, which means that AWS shares security responsibilities with customers. In this model, AWS is responsible for the security of everything from the hypervisor level to the operating system. AWS helps to reduce security risks in numerous ways. AWS leverages AWS automation and tools available to help customers mitigate the most severe security risks, including denial of service attacks. Provides the AWS Identity and Access Management, or IAM service, to centrally manage users and credentials, which helps customers reduce or eliminate the existence of rogue servers. And leverages our roster of 30-plus compliance certifications and accreditations to help our customers build secure, compliance-ready environments. Our customers are confident in our security. Rob Alexander, Chief Information Officer at Capital One, says, "We believe AWS enables us to operate more securely in the public cloud than we can in our own data centers." Common causes for software resilience failures include resource exhaustion, like runaway processes, memory leaks, and file growth. Computational or logic errors, such as faulty references, deallocated memory, corrupt pointers, sync errors, and race conditions. Inadequate monitoring, such as the inability to identify issues. And failed upgrades, such as intercompatibility. How does AWS help with software failures? AWS provides services in a way that allows customers to increase or decrease the resources they need and have AWS manage the changes. To provide software resilience, AWS offers blue and green deployments that allow for quick rollbacks, automates continuous integration and continuous delivery workflow, runs smaller code deployments to reduce unit, integration, and system bugs, provides current and secure resources with OS patching, and creates and manages a collection of related AWS resources. Causes for infrastructure failure include hardware failure of servers, storage, or networks, natural disasters like hurricanes, floods, and earthquakes, power outages including failed power supplies and batteries, volumetric attacks like DDoS, DNS amplification, or UDP ICMP floods. AWS helps reduce infrastructure failures in numerous ways. AWS continues to expand our world-class infrastructure and leads the industry in improving data centers on a massive scale. Our customers can run applications and failover across multiple availability zones and regions. AWS systems are designed to be highly available and durable. S3 is designed to provide 11 nines of durability and 4 nines of availability. Amazon EC2 is designed for 4 nines of availability, and Amazon EBS volumes are designed for 5 nines of availability. As a standard, each AWS availability zone in each region is redundantly connected to multiple Tier 1 transit providers. And at AWS, every compute instance is served by 2 independent power sources, each with utility, UPS, and backup generator power. Here are some customer examples that show increased operational resilience achieved by our customers when they implemented AWS. Macmillan improved SAP availability from 90% to almost 100% with AWS. TravelStart reduced downtime by 25%. Stitcher migrated to AWS with zero downtime and improved availability to over 99.99%. In this module, you learned the meaning and importance of operational resilience, common causes and effects of operational resilience failures, the causes and impacts of downtime. This concludes the operational resilience module. Welcome to the Business Agility module. As discussed in previous modules, this module continues to focus on the business value aspects of cloud economics. Previously, you learned about the 4 pillars of the cloud value framework. Then, business agility is about delivering more, such as responding faster, experimenting more, and delivering results in the same or less amount of time. It means being able to deliver more. Business agility is a broad area of value that primarily addresses customers' increased opportunities to experiment and respond faster. Here you can see an industry-agnostic list based on key performance indicators, or KPIs, where you will learn more about 3 key metrics: time to market for new applications, features per release, value or revenue per. In August 2018, AWS conducted a benchmarking insights analysis. Some of the most important activities that a healthy business must do to continue to grow and innovate are to scope, prioritize, and take on new initiatives. You can think about the initiative process like a project funnel. Many initiatives are enabled by IT. Most organizations with an on-premises infrastructure must think carefully about how and when to spend scarce resources in pursuit of each initiative. AWS gives organizations greater flexibility. For example, consider an organization that starts with 20 good initiatives. Instead of picking one, the organization sets up a test and development environment in minutes and experiments with each initiative. After their first round of experiments, they decide to deploy. DevOps practices help customers deliver software faster, more reliably, and with fewer errors. Two key DevOps-related IT performance dimensions are code throughput and system stability. The first two rows in the table correspond to code throughput. Throughput is measured by how frequently a team is able to deploy code and how quickly it can move from committing code to deploying it. Rows 3 and 4 correspond to system stability. Stability is measured. Here's an example based on a customer-facing application for a subscriber-based company. A company wanted to understand the impact of improving the conversion rates for a customer-facing application. This company is in the subscription-based business. The ability to offer additional services to customers is a critical method to increase customer loyalty and drive additional revenue. Previously, the company had 40-minute wait times due to queues for customers waiting to purchase new services, and conversion rates from click-to-purchase finalization were 60%. The solution included using Amazon Simple Notification Service, or Amazon SNS, and AWS Lambda to eliminate the queues and reduce wait times to less than seconds. With this change, conversion rates increased to 70%. As far as KPIs, time to market was reduced from 6 months to 1 month. Here are a few customer examples. AFG. In this module, you learned about the concept of business agility, key performance indicators used to measure business agility, how increased business agility can. This concludes the business agility module. Please continue to the cloud financial management. IT organizations balance delivering the benefits of a cloud strategy while maintaining governance. Cloud strategy includes agility, scale, resiliency, and cost savings, while maintaining governance includes compliance and efficient use of resources. AWS Cloud Management Tools partners have proven customer success in delivering cloud strategies and maintaining governance. Their customers can confidently manage AWS environments using a guardrails approach, while monitoring for any non-compliant activities. These partners specialize in providing solutions for administration and provisioning, cloud governance, and resource and cost optimization. Click the link to see all of the partners who have these competencies. The third option is to use the tools that AWS provides, such as the AWS Cost Explorer. AWS Cost Explorer is a free tool that helps customers dive deeper into their cost and usage data to identify trends, pinpoint cost drivers, and detect anomalies. In this example, the report shows the percentage of purchased RIs in use. Here, the cost is. The next key area of cloud financial management is cost optimization. The first best practice of cost optimization is right-sizing instances. This means selecting the least expensive instance available that meets the functional and performance requirements. Right-sizing is AWS Cost Explorer. The second best practice of cost optimization is increasing elasticity. In regards to increasing elasticity for cost optimization, reviewing production versus non-production instances is key. Instances that are non-production, such as dev, test, and QA, may not need to run during non-working hours, such as nights and weekends. In these cases, these servers can be shut down and will stop incurring charges if they are not reserved instances. Typically, when a non-production instance has a usage percentage less than or equal to 36%, it is less expensive to use on-demand pricing versus reserved instances. Note that a customer can create an AWS Lambda function that can automate the starting and stopping of instances based on parameters like idling and time of day. The third best practice of cost optimization is choosing the right pricing model. In this section, you will learn about the benefits and use cases of both reserved and spot. First, you will look at reserved instances. Using reserved instances can have a significant impact on savings compared to on-demand, in some cases up to 75%. Typically, while using reserved instances in certain cases, customers can take advantage of regional benefits. Regional benefits can simplify reserved instance optimization by allowing a reserved instance to be applied for the whole AWS region rather than just a specific availability zone, which can simplify capacity planning. Suppose an AWS user launches early rate to any instance in a specified region. AWS Cost Explorer generates RI recommendations for AWS services, including Amazon EC2, RDS, Redshift, Elasticache, and Elasticsearch. You can use the recommendations feature to perform. Customers can combine regional RIs with capacity reservations to benefit. Welcome to the Introduction to Migration Portfolio Assessment, or MPA, module. Portfolio discovery and analysis help customers collect and analyze data. Customers can use this data to validate their business cases and create migration plans. Customers can also use this data to estimate the level of effort and costs associated with migration, as well as estimate the annual run rates for compute and storage resources on AWS. This information often defines the complete dataset required to properly analyze and prioritize application migrations. The AWS Migration Portfolio Assessment, or MPA, is a web application that automates the portfolio analysis process. This MPA helps customers with their business case validations and migration plans. This course focuses on the business case validation aspect. So, who can use the MPA tool? The MPA tool can be used by consultants and sales teams focused on on-premises to cloud or cloud-to-cloud migration engagements and cost analyses. With high-fidelity data, migration success managers, or MSMs, and migration leads responsible for creating and executing the migration plan can use the MPA to create a migration plan. How can the MPA help? The MPA can help in a variety of ways. It can be used in the early stages of engagement to create a directional business case, known as discovery. The MPA's key features are shown here. In this module, you will learn about each of these features at a high level. Then, in the next module, one key MPA feature is the data import feature. MPA data import is a guided workflow to import and validate on-premises data. The MPA uses server usage data to map the source recommendations on a server. Once a data import is complete, you can do the MPA lists the open standard. Customers aren't required to set an instance family or secure MPA access is log in to considered for MPA access. In this module, you learned the Migration Portfolio Assessment is a web application that automates the process of portfolio analysis and helps customers validate the migration business case and create a migration plan. MPA is available to all advanced and premier tier partners. Thank you for Welcome to the Cost Savings with the Migration Portfolio Assessment module. The first phase of conducting a cost savings analysis is to create an MPA portfolio and prepare the data. In the context of MPA, a portfolio is an on-premises infrastructure and application dataset that will be analyzed. The what-if scenarios are an incredibly valuable tool to aid in your customer conversations. We encourage you to leverage these as part of building